I feel like I've already kind of coalesced on what some of the really interesting problems are going to be. And we can talk all about that later. But for now, I've been asked to give you some insight into what we're doing at Expedia. I know this is a tech talk, but I wanted to, or I kind of pitched this talk at the level of somebody who maybe has some authority in the company. Maybe you're interested in moving to the cloud, so maybe a lot of these details to my fiducial listener is not quite tech savvy yet, but I'm all about the tech stuff. So if you want to ask very specific questions, you want to drill down deep, feel free, we'll get to it. Right, so let's kind of set up the problem, the user story for someone coming into this conference or to a cloud-based system. You've been asked to bring your infrastructure from your company up into the cloud, and you've been promised all kinds of really great things, right? For example, let's get rid of the data silos, right? Let's give everyone access to the individual data sets. Let's democratize the machine learning that goes with it. And machine learning keeps coming up over and over again, right? So there's lots of strong motivation to get out there. So it's understandable for, and then, for reasons wanting to get yourself on the cloud. But maybe like me, you were kind of brought in kind of halfway, like the process has already started. So there's another possible use case for those of you out there where your data lake, that's something that has been promised, it's actually more of a data swamp. It's a mess, it's impenetrable, you have no idea what's going on, and you're here for help. So I'm not sure that what I have to say will help you. I sure hope it does. But I think in aggregate, maybe we can talk about and assemble some sort of strategies for dealing with this sort of thing. So one question is, well, what do you mean swamp? Like, let's get real, right? So what really happens, nuts and bolts, when you start putting everything in one big pot and say, OK, here's your data, now go and play, right? So you get a mess. It's just like a really messy warehouse. So what are some abstract things that we typically think about, at least as a tech company, an internet company? We log people's logins. We talk about whether or not they purchased something. What was impressed? What did they see on the website? Did they click on something? Did they hover over something? Now you can even assess to see how far they scrolled down the website. When did they spend their time? These kinds of data are pretty abstract, and they're pretty well understood means of like collecting them. But it's still a mess, right? Because the engineers that help you set up a website that has all this kind of stuff, right? So for Expedia, we're a travel company. And one of the unique things about Expedia is we have not only hotels, right, and planes, but also trains, and also boats, and also rental cars, and we can even sell you things to do. So there's a whole lots of different engineering teams that go into each and every single product or service. So before you get to the chance to click on something, let alone purchase it, some untold number of microservices have gone through. And each one of those microservices triggered a log. Each one of those logs isn't saved. And lo and behold, right, just as has been brought up earlier today, sometimes you go into those logs and you find interesting things. So we did this, for example, in the hotel sort logs. We'll dig into it, realize, wow, we can do some predictive analytics just based on what people did. So there's that. But then every line of business, I guess that's what I would just point out, every line of business has its own structure. And what I mean by that, I mean like intellectual structure, right? So for a hotel is a very specific item in a very specific place, right? But when you purchase a flight, you have one way, round trip, and then here's some industry lingo for if you want to take home something to impress your friends. Open jaw, OJ. OJ stands for if you say you start off at JFK and you go to LAX and you come back to LaGuardia. That would be an open jaw, right? It's not exactly closed. Or you can talk about multi-city sort of stuff, right? So these data structures are different, right? So it doesn't fit into this nice paradigm. So you have to deal with a slightly more complicated, abstract level of infrastructure, which adds to the mess, the complexity, if you like. And then finally, once you have all of this set up, you want to A/B test things. So the things that you're trying to model, the data that you're trying to model, the pipelines you're trying to set up are constantly in flux. Because maybe you're not just testing algorithms. Maybe you want to test, do I want smiley faces? Do I want frowny faces? Do I want blue smiley faces? All these kinds of things you want to find some new way to track. So this is a mess. Another way to phrase the problem is, so now they've given you all of this data, right? And can you please turn this junk, this huge storeroom of mess, into cash? And they give you some buzzwords like Spark, Hadoop, which we've been using a lot of, and so that's why we're here today, right? To talk about data platforms that we can do, do data science to make money. So this is by way of a preview of how I'm going to organize the talk. I'm going to give you a little bit of context, a little bit of disclaimer about things I have to say. And then I'm going to give you a lightning review of data platforms, partially because I assume that some of you are not on a data platform, partially because it tells my own story and help you give further context to where I come from and my perspective on things, and partially just to have 3 points. You got one of the jokes, awesome. All right, cool, so context, disclaimer, I'm an academic. I come from theoretical physics background. So I am not a machine learning PhD, I'm a PhD in physics. So, in that sense, the way I think about things is always in terms of, right, spherical cows. Like on the grand scheme of items from the ways of thinking about things, we have theoretical physicists on one end, and you have practicing economists on the other end, right? So I'm way over here. So everything I have to say is going to be modeled in that direction. So if something sounds really abstract, although I've noticed there's a lot of, like machine learning is a great abstract word that people have been throwing around today. So if something sounds abstract, it probably is, and we can dig into it and talk about it. Okay? And at Expedia, we still have a lot of work to do. We're still trying to completely move ourselves into the cloud. So this is not something that by any means we're done with. So definitely open to suggestions. So I am going to assume that you are going to take my opinion as one of an ensemble of opinions that you've collected over the date, or over this workshop today. So good. So before we get to the meat of the talk, let me just do a quick lightning review of data platforms. Everyone remembers queuing. Has anyone here worked with supercomputers? Ever? Yeah, right? So you remember, anyone, you didn't? So I went to graduate school in Texas, and so there were like a couple of really big high-performance computers that we had access to at Texas A&M, and like Lone Star was one of them. And you had to stay up really late because we were first-year grad students, and we didn't have the appropriate, what would you call it, queue priority. So we would have to send off our code at 3 in the morning in order to get processed. And this is just to do homework, right? So there was a lot of waiting around, a lot of public kind of consumption of the same resources. So it was great to come to industry and discover that, hey, we have our own. We have our own supercomputers. And there's multiple wow, we got 2 buildings. One of them actually is in Phoenix. So it's kind of cool to visit. So in some sense, that was kind of nice, especially considering how our team, the team that evolved into the data science team at Expedia, really kind of started pushing Hive and Hadoop kind of early on. And so at first, it was awesome. And then you start to realize that you got a bunch of business intelligence users, which is fine. It's good. It's good to democratize things. But then they start running table scans over the entire data. Like, they don't know what a partition is. And until somebody finally said, no, you're not allowed to run this query unless there's a where clause with the partition. Ooh, boy. And just to give you some further context, other things that we run into, I talked about microservice logs that tend to be useful for things, especially for debugging. So the microservice log that we have that deals with kind of a sorting, each row is 3 megabytes, each row. Each row represents one user's search, right? So if you're interested in the past day's worth of searches and you're trying to query that, maybe you can get a result. But if you're asking about something on a time scale of weeks or months, forget about it, right? So even that is not good enough. So now we're in the cloud, where everything's virtualized. You can call virtual things from virtual things. But the point is that you do. So this was supposed to be the slide where I sell you on the cloud, but people have done a lot of that. So let me just hit the high points just for the sake of the video camera, if you like. One is you can assign tasks their own virtual hardware. So for example, these search logs that I just mentioned, we can spin up our own Presto cluster, dedicate the Presto cluster to, say, 3 months of data. And that is the only thing that cluster has to do. And so when we run queries we want to run these queries against this massive table to debug things or see how the search results are doing. We can do it quickly, because only 1 or 2 people need to do this at a time. So that's pretty awesome. You can expand or contract on demand. That's like the killer app. That's how Qubel came in. That's how our engineering team welcomed them with open arms, because not only can they expand on demand, but they can contract and save a lot of money. And that's actually, we've observed a lot of that, so that's awesome. And something that I feel like doesn't really get appreciated very much is this concept of real-time hot swapping. I can develop a productionalized version and have it running, and I can do it in parallel, and then I just turn this one off. Like I don't have to build up a new infrastructure. I can have as many instances of my production code going as I want. So that's kind of cool, right? Software updates built in, blah blah blah. You kind of know all this. So where do we go from here? So this is kind of the meat of the talk. These are the things that I really kind of wanted to talk about today. Again, going to the spirit of like, this is my opinion, and this is a theoretical physicist opinion. These are my kind of idiosyncratic organizing principles. Again, with a typo. Gosh, sorry. IOPS. I got just really obsessed with this acronym, so that's why I haven't really paid attention to the spelling. So these are kind of the IOPS, the organizing principles that I think are important. These are things that I worry about. These are things that I kind of yell at people, or at least yell with people about. So hopefully through these individual items, I can talk to you about some more kind of concrete examples of stuff that we ran into. And like I said, feel free to jump in if you have questions. Or at the end, of course, I'll leave plenty of time for questions. And if you don't take it, I'm going to keep talking. It's just so you know. All right, so clarity. Data clarity is key. So this is the whole thing, right? Let's break down the silos and let's put all the data into one big giant lake. We did that, and it is a mess. It is a mess. Where is the data? Where is what data? Car data. Car data specific to pickup location, drop-off location, geography. Where is that? Who owns what fields, right? So, okay, so let's get some context going. So imagine, if you will, you have some sort of infrastructure, some sort of setup. So you have for every page event that happens on your website, you log it in some way, and you probably log it in some way that's structured so at least computers can understand it. And the fancy way to do that these days is with JSON, right? So you get this huge nested representation of all the possible objects that could happen that's supposed to be logs. And each one of those, so for that chunk of that JSON schema that's tied to, say, car rentals, you've got a chunk that specifically represents pickup location, geography, details, right? Who owns that field? Well, the car engineers do, right? Not the data, not the cloud folk, not the machine learning folk, but the car people own that. But who in the car team can I contact when one of those fields go missing, right? So this is where these are the problems that you kind of run into, right? Like, what does this field even mean? So there's also a lot of holdover, I know, from old kind of Microsoft SQL days where people had like a size limit on how many characters a field could be called, right? So you get like this practice of removing all the vowels, and you look at like, what does it even mean? So yeah, so if you're looking for like stupid best practices that will actually save you a lot of time and headache in the future, especially if you don't want to explain a table to somebody, just use human readable language when you're naming fields. That's something you can definitely do. Fields, classes, instances, file names, directories, S3 buckets, human readable. Why not? We have the space for it. Doesn't matter. You know, where did this field go? When like every once in a while something will just disappear, right? So some other things that you might worry about is like case sensitivity, camel case versus not camel case. What I'm thinking of in particular is, this might be too in the weeds, but I'm just going to give you a good example. Seems sufficiently abstract, like hopscotch. Is that one word or two words? Because it matters if you're using camel case, right? Hopscotch returns null. Hopscotch returns a value. Things to worry about, especially when designing your names, right? So things to think about. Why is this field null? Who do I talk to? Who do I call on? So again, with the spherical cal, right? But publish this internally. If you're going to be the person in charge of, you might want to design. So this is, again, assuming you're going to design your infrastructure in some way. Like, if you're going to build a massive data lake and you're going to break down all the silos, at least record what silos were where and who's responsible for inserting things. So if you think about it in terms of hydrology, so I'm in Seattle, right, Pacific Northwest. We have a lot of rivers, we have a lot of glaciers, we have a lot of cascades. Think about it as hydrology. Like, what is coming into your lake, your data lake, and what is coming out, right? So don't let junk in. It's better to have no data than bad data. More on data quality. Here's another thing, right? So this is not a critique. This is not a best practice thing. This is just what happened, right? So suppose you've got some nested JSON and you've got like small, tiny little files that are gzipped, right? And this just happens because it's just what your system, the engineers in your system designed, and maybe it has a really good purpose. And that's great unless you're using Spark, in which case it's a mess because Spark doesn't like those little files. They like big chunks They like big chunks, and they don't like these kind of like weird like compression schemes where you can't split them up. So just like tune the type of files that you have to the task at hand. And Charles is in the room. Charles is going to have a really great talk where he's going to tell us all about this. So go and see his talk, because this, I'm very excited about this, because this is one of these things where we start working with Qubole and start working with people who work on Spark and that sort of thing. When we first started doing our car sort models, we're trying to pull impressions data that we can train a machine learning model on. 1 day's worth of data took 2 days to pull. You're not going to get anywhere. It now pulls in it pulls in seconds level. So thanks to a lot of work that Charles did, but also thanks to doing other things like specifying the schema when you're loading in Parquet files, that sort of thing. So it has a 2 order of magnitude influence, at least on our workflow. So yeah, be careful with your data and how you organize your data and think about it. Okay, so that was the first principle, clarity. Clarity is really important. That's why I put it first. Second, engineers are not data scientists. They have different. Who's the any data scientists in the room? Yeah, any engineers in the room? Yeah, right. So to the data scientists, engineers are not data scientists. They have different priorities than you. They have different philosophies than you. They are. Why would you need to do that? So here's one thing. So Mike is also in the room. And I remember distinctly, like, thank you for setting this up for us. So this is one of the things that was like a glaring omission when it came to things that data scientists need. Scratch space. When we moved onto the cloud, hey, I'm trying to build up a training set so I can train a model on it. Where do I save my data? What do you mean? It took a long time for us to establish just to carve out some space in S3 that we could just create a bucket, put data in. Maybe we also, right? So, like, this is a very, to a data scientist, you're like, what do you mean? But to engineers, they just weren't thinking that way, right? So scratch space. Some other things, like, and yeah, sorry in advance. I'm sure a lot of you heard me moan about this before, but these are other things that you really need to kind of consider when you're moving to the cloud, right? This is kind of incidental complexity, right? So cluster bootstrap permissions, because as a data scientist, I want to try out new algorithms all the time. I kind of need to cycle through. Maybe the first, I don't have time to go and talk to somebody and say, hey, by the way, I'd like to install this package, but I don't know what the parameters are, and I don't know what I need. I kind of have it working on my own computer, but I know that we're doing distributed stuff, right? I don't have time for that. So it would be much easier if I can cycle through the permissions myself, right? So that's something to consider. Access to S3 buckets. So it's great that you have a system that's kind of, you have like a test account and an integration account and a prod account and all this kind of stuff. But if you need to find 3 separate, if you have to chase email to email to email just to get access to data, like, it's just not going to happen. And so, I mean, a lot of the stuff that we did when we first started out, before we kind of moved to the cloud for real, my boss, Dan Friedman, VP of data science at Expedia, he likes to call, like, we were scrappy. We would go in and we would like arm wrestle down engineers and say, we need this data. The Omniture guys, anyone worked with Omniture before? It's like a site analytics. Like they store the data that people clicked on. Like, we wrestled them down. We're like, we need this list put in Omniture somehow. Get it there. And we would get it, and then we'd pull the data set ourselves, and we would force it to happen. We'd carve out space. But with the cloud, with all these great services, like, we don't want to worry about any of this anymore, and we don't have to if you don't want to. So careful about S3 buckets. And I'll have a little bit more to say about that in a second. Sandbox clusters, right? Same sort of thing. So I need a little cluster to practice on, to fine-tune things, to get before I generate a really big productionalized environment. So, maybe from an engineering perspective, you think about this in terms of test and int. I'll get this to another point later, but those words aren't immediately obvious to us, what that means. Yeah. One thing we need to do is share notebooks across accounts. So Expedia is a conglomerate. We own lots of companies, and for good reason. Like, I feel like we have a lot of benefits to add, right? But one of the things we've recently acquired is HomeAway. HomeAway is a vacation rentals company. And HomeAway does a lot of interesting things with their sort as well, or at least they're trying to. And we're kind of trying to collaborate, because, hey, we've got this years of experience with hotel sort. You clearly need some help with your hotel sort. Sorry, guys. We could probably benefit, I guess what the way to say it is, like, we could benefit from Exchange. But they're on a different account. They're a completely different Amazon account. How do we exchange notebooks? How can we share, hey, like, to share things? So that's something that you need to add functionality to. So how did we solve this? Cubo. Cubo links to GitHub. Awesome. Thank you. Yeah, right? Yeah. Boom. Final point about this. We are data scientists. We do not speak AIM. We do not speak roles, IAM roles. You cannot simply say, if you want access, fill out this form. What does that even mean? So, OK, careful. Another thing, I'll save it. I'll save it for one of my next points. Right, so one other thing, and so I'm sorry, I don't have the link for you. I can hunt it down, but there was a really great article, which is now nameless, apologies, which is engineers should not write ETLs. Just look it up, right? It's a really great article. So write your own pipeline, and the moral of the story is you need to control the data that goes into your model, right? So you should write your own pipeline. Let the engineers do more abstract, fun things. Otherwise, you kind of have to sit down and explain to the engineers what data science is. And in fact, you should do this anyway, so never mind else. Explain to engineers what data science is, so that way when you need to find that pickup location for a car geography information, say that you want to get the lat long of where Enterprise Rent-A-Car is in Ravenna in Seattle. And they say, well, who cares? You say, haha, well, I can make $2 million a year if I only had that data. Oh, now all of a sudden you're helping the company out, you're making lots of money, right? So you need to explain data science to engineers. PMs are not data scientists. Any PMs in the house? And by P, I mean product or project. OK, good. Sorry. Once upon a time in a flight data lake, we had a data lake specifically devoted to flights, right? So this is a little bit off the car sort topic. Only 10% of search impressions were recorded. What does that mean? What I mean is to say is the cheapest 10% of all possible things that a user could have purchased were recorded. So now imagine my position. I'm a data scientist